Good afternoon, everyone. Today we're going to use the chain rule and the product rule to differentiate this function f of x and then evaluate that derivative function when x has a value of 1. Okay, so let's start by applying the product rule to, let's call this first part u of x, if you're familiar with the notation of u of x and v of x in the way that my students are. The product rule says that f prime of x is the derivative of u of x times v of x plus u of x times the derivative of v of x. And so we're going to start by differentiating u of x. That'll be 12x cubed. And then we're going to write v of x as it is. So we'll have x squared minus 3 over x all to the power of 10 plus, now we're going to leave u of x by itself and use the chain rule to differentiate v of x. Okay, so the exponent of 10 multiplies out front, and then the exponent of 10 goes down by 1 to become 9, and we multiply the entire expression by the derivative of the stuff inside the brackets. The derivative of x squared is 2x, and the derivative of 1 over x, I'll make that a side note, the derivative of 1 over x, I'll remind you 1 over x can be expressed as x to the negative 1. And if we differentiate that, we get negative 1 over x squared, right? That 3 on top just stays as a 3. And so the derivative of 1 over x is negative 1 over x squared. So negative 1 over x squared is positive 1 over x squared, right? And the negative with that negative make a plus. And then we have the 3 on top. And so we have 3 over x squared, like so. Okay, and now we're going to group this together. And so our derivative function f prime of x is 12x cubed x squared minus 3 over x all to the power of 10 plus, and we'll have, I'll multiply the 10 by the 3, so we'll say plus 30x to the 4 times 2x plus 3 over x squared times x squared minus 3 over x all to the power of 9, like so. And then can we simplify this a little bit? Let's see what we can do. We can simplify this at least a tiny bit. This can be written as, we have an x squared minus 3 over x to the power of 9 in both terms, right? So let's factor that. And so we'll have, in the first term, we'll have 12x cubed times one factor of this, right? So times x squared minus 3 over x plus, let's multiply through this bracket. And so 30x to the 4 times 2x is 60x to the 5. And then 30x to the 4 times 3 over x squared is plus 90x squared, right? And we have all of this times what we factored out of both terms, i.e. times x squared minus 3x all to the power of 9. And this should simplify down a little bit. If we multiply through these brackets, we have 12x to the 5 minus 12 times 3 is 36. X cubed over x is x squared plus 60x to the 5 plus 90x squared, again times x squared minus 3 over x to the power of 9. Right, we're going to plug in the value of x to the 1 afterwards, and so it's nice to simplify this down as much as possible before we start substituting in values of x, right? That is a wise strategy. And so now we can group like terms. 12x to the 5 plus 60x to the 5 is 72x to the 5. And then 90x squared minus 36x squared is plus 54x squared times x squared minus 3 over x to the power of 9. And that's definitely as simple as we're going to get it. We don't want to expand this using binomial theorem. That's a whole lot of work for not that much payoff. And so now let's evaluate f prime of 1 like we were asked to do from the beginning. f prime of 1, meaning the slope of the line that would be tangent to this curve at precisely the point where x equals 1. The slope of that tangent line, the gradient of that tangent line, is going to be the value that comes out of plugging x is equal to 1 into this expression. And so we'll have 72 times 1 to the power 5 plus 54 times 1 squared, all times 1 squared minus 3 over 1 to the power of 9. That means 72, 1 to the 5 is 1, plus 54, 1 to the 2 is 1, times 1 minus 3 to the power of 9. And so this is not going to be that straightforward. 72 plus 54 have a sum of 126. This is going to be negative 2 to the 9, meaning 126 times negative 2 to the 9 is negative 512. And so the slope of our tangent line, I'm going to run and grab a calculator. Feel free to do the same. Is 126 times 512 is we have a slope of negative 64,512, which is pretty outrageous, but given the fact that I made this f of x function up arbitrarily, that's what we get. And so again, this is an example of using the product rule in combination with the chain rule and applying that derivative function to get the slope of the tangent line at a specific point on our curve f of x. The slope of that tangent line is negative 64,512. That's a very steep downwards sloping line. So I hope this helps. Thank you for watching and take care.